So I want to welcome everybody to tonight's webinar. I'm Joe Deli Carpini, the Science and Operations Officer for the National Weather Service in Boston. And with me tonight is one of our meteorologists and frequent presenters, Rodney Chai. We're going to take you through the events of 2020, and then Rodney will give a briefing on the ocean-enhanced snow. He's been working that forecast desk all week, and I'll take a look at the storm for early next week. As a reminder, first of all, you can use the chat box if you have any questions. We have everybody on mute because we have a lot of people with us. We'll answer as many questions as we can at the end, especially focusing on our weather briefing. But always check our webinar page for the latest schedule. You can bookmark it, and also we'll make announcements on social media. We have a couple of webinars coming up next week, looking at the top 10 southern New England winter storms of all time. And an event review of the January 16th snow across the interior. In the event we are under a major winter storm Tuesday, there is a slight chance we'd have to reschedule that. So if we do and you're registered, you'll receive an email letting you know. But hopefully we'll be able to have that one as scheduled. And of course, we record every one of our webinars. They're available on our YouTube channel if you want to go back and review any of them. So I'm going to start with kind of the first half of the year and then hand it off to Rodney. The first storm is the March 23rd winter storm. This was, we started doing a lot of more of these event reviews kind of after COVID hit, and started these public webinars too, which we really enjoy doing. This was kind of the first storm really of kind of what was a lackluster winter. We kind of had a lot of snow kind of at the end, and you'll see, some of them detailed here. This was a storm that really hit, upstate New York into central and northern New England. Not so much here in southern New England, except for some of the higher elevations. And you can see some of the snowfall totals here. East Hawley about 10 inches, and West Townsend and Royalston 8, and a little bit more over the border into New Hampshire. There was some snow at the beginning of the storm, closer to the coast and down across Connecticut. This eventually changed to rain, and there was quite a bit of it. You can see some of the rainfall totals here, as much as 2.7 inches in Westwood. That's rain and some melted snow, but really widespread, 2-inch plus rainfall amounts after the snow occurred. Now, during the late afternoon, we were looking at some webcams out along Interstate 84 to kind of see what was happening as the snow moved in. And you could see for the most part there were wet roadways, but there was some accumulation of slush in some of the hills. You can see definitely, on the sides of the road there. This is looking from Southington up to New Britain and into Hartford. Now, when we look at the radar loop, you can actually see the transition from snow to rain pretty well. Focus here on the upper right, which is what's called our correlation coefficient. If you looked at our winter weather webinars, we've shown this a few times. For this band of lower values that moves from south to north is actually the transition from rain to snow. You've got a lot of snowflakes mixed with raindrops. It's kind of all over the place from what the radar can measure, so there's no uniformity to it. That's why we have lower values. You can see ahead of it, it's all purple, that's all snow, and behind it, it's kind of all rain. So this just shows the transition from kind of 3 to 7 p.m. that evening. And you can see behind this band a lot of heavy rain moving up into the area. We also had a pretty good band of heavy snow to the north along Route 2 into northeast Massachusetts later in the evening. This produced up to 2 inches per hour. You can see it might be hard to see the map, but this is Lowell here, Worcester down here. So really along the Route 2 corridor of northern Massachusetts, had a quick band of heavy snow at night. And you can kind of see that happening here as well. If you look, seeing this band of heavy rain move up, it kind of transitions to snow. Well, at the same time, we were looking at that rain snow line moving north earlier in the evening. It actually starts to collapse back toward Boston. You can see it right here, and then you'll see it pivot kind of back down toward Boston toward the end of the loop. So many of these areas changed to rain and then flipped over back to snow across the Merrimack Valley. So moving on to April, kind of the winter that never ended. Rodney took this photo on the left of the April 17th to 18th snowstorm. And this one, not a tremendous snow, but not bad for the middle of April. This was more of an elevation snow with about 5 inches in Grafton, 4 in Worcester. You can see Pomfret at 5, and even parts of northwest Rhode Island, and then over toward the Berkshires. But in general, even areas toward the coast, 1 to 3 inch snowfall. even into the Hartford area as well. So little decorative snow for late in the year when I think we were all kind of ready for some spring. This particular storm formed over the Rockies. It actually had a long history, produced blizzard conditions across parts of the plains, and then passed south of New England and eventually moved offshore and drew some colder air into the region. When we were looking at the forecast, this is the HREF, which is our high-resolution ensemble forecast, which we show quite a bit. It actually did a nice job depicting the heaviest snow, mainly along and north of the Mass Pike, and then a transition to rain across Connecticut, Rhode Island, and southeast Massachusetts after some initial snow. Here was a look at kind of the forecast that we had, the last one going out the door. It certainly highlighted the higher terrain very well, a little bit overdone by an inch or two, but overall not a terrible forecast for a late season event, which usually are the challenging ones for us at the office. And then, of course, on to May, and we had a late season snowstorm, or light snow, but more significantly, a pretty good blast of cold air. And I think really by then we were kind of waiting for spring. The spring flowers were up, but they got covered in a coating of snow. Again, not a tremendous amount of snow, as you can see here on the left, generally up to about an inch or so. I think the max was 1.4 inches in Rowe out in Franklin County, but a couple of nice decorative pictures here in Staffordville and Hubbardston and at some of the higher elevations. Now, talking about the cold, for Boston, it set the record for the coldest daily maximum temperature with a high of 44. That broke the previous record cold high temperature of 45 degrees in 1966 and was 20 degrees below normal. You can see Worcester tied their coldest from 1972 at 40 degrees, and Providence and Hartford came pretty close. They were in the top 3 at 48 degrees, just falling shy of the records of 45, so definitely unseasonably cold. Then a week later, hey, it was in the severe weather season. Why not? And this was, prior to October 7th, the most significant severe weather outbreak we had all summer, really. This was a long-lived squall line that started out in upstate New York, raced through the Albany area, and then across southern New England, primarily north of the Pike, but there was some damage to the south. These are all wind damage reports, so quite a bit of wind damage across the region. We had most significant damage was over in Groton and Westford and Pepperell. And this is a drone shot of some of the wind damage from straight line winds. You can see all of the trees kind of aligned in the same direction, really no twisting, which would be indicative of a tornado. So this was a pretty good event. And in Pepperell, the microburst, we actually ended up doing a storm survey for this because of the significant winds. And maximum winds were estimated to be about 90 to 100 miles per hour based upon the damage, with a path length of about 1,000 feet. And these photos are courtesy of Pepperell Emergency Management. You can see quite a bit of tree damage, especially here on the right before things are really cleaned up, but just a lot of fallen trees across the area. Here's a look at the radar loop for the event. And we should note that the Taunton radar, K-Box, was actually out of service. It was undergoing its life expectancy upgrade for that about a 2-week period. So we relied on the radar from Albany to really show this event well, and an FAA radar, which is located in South Weymouth, Mass. But this is looking at the squall line approaching Western Mass and moving through the region. You can see on the right, this is base velocity, which is the measured wind. A lot of greens and blues, which are showing winds in excess of 40 to 50 miles per hour in that case. And then we moved on to June. We had a pretty good flash flood event in Norwood, which is actually where I live. And this was a photo of the downtown area near the police department, if you're familiar with the town. Quite a bit of significant urban flooding. And this really formed as a result of some outflow. This was earlier in the afternoon. We had a cluster of thunderstorms move through Boston, and they set out what's called an outflow boundary or a rush of cooler air. This boundary, which you can see right here on the radar, kind of stalled right near the Norwood area, and it provides a source of lift. So when you have hot and humid air and this kind of outflow boundary moves through, it can generate new thunderstorms, and that certainly did. You can see a few storms here popping up east of Worcester. These storms developed, moved east along what was really a stationary boundary, and did what we call training, just moving over the same area over and over again, and dumped over 4 inches of rain in 1 hour in that area. Here's a close-up of a little bit later in the afternoon. This was a little after 4 p.m., and you can see now the boundary has shifted a little bit south, but now we've got quite a few thunderstorms moving east across the area, Norwood being located about here. And by that time, we had several flash flood warnings out and even a flash flood emergency for that particular situation. Some of the rainfall reports you can see here. Bellingham actually led the pack with over 4.8 inches. This was my station in Norwood at over 4.4. Most of that fell within 1 hour, and you can see really widespread across the region here, anywhere from about 3 to 4 inches. That was even a 5-inch report across the southeast part of Worcester County that resulted in pretty rapid onset of significant flash flooding. And just put this in perspective, we went back to take a look and said, how rare was this? Well, 4 inches per hour for the Norwood area. We're taking a look at, this is what's called the NOAA Atlas 14, which gives you kind of an estimate of the frequency of heavy rain. So starting on the left, this would be the durations, 60 minutes being 1 hour. And then on the right, we have to find where 4 inches is, and it lies somewhere between a once in a 500-year event and a once in a 1,000-year event. So this was certainly a very rare event for the area to have 4 inches of rain in 1 hour. Again, doesn't mean it's going to happen every 500 or 1,000 years, but there's a chance of 1 in every 500 years of reaching that. So certainly that was a rare event. And actually to this day, Norwood Hospital remains closed because there was quite a bit of flood damage, especially from what came in through the roof. And that's still being worked on. Here's a look. We did a simulation of kind of what's looking at is called stream flow. So what you're looking at here on the left is units of stream flow going up from low to high, and in time from left to right. Where the black is actually where the flooding was observed at Norwood Hospital, and you can see just a rapid shoot up in about an hour's time from almost nothing to significant stream flow across the region. And this is looking at the stream flow, what's called hydrophobic, meaning on paved surfaces, which the values you can see are certainly a lot higher because nothing's getting into the ground. So just a quick representation of showing how quick the runoff really got into the area. So then, of course, 2020 wouldn't be complete without a few tropical systems too. Why not? The first one, Tropical Storm Faye, on July 11th, developed off the North Carolina coast and moved up the Atlantic seaboard. It formed into a tropical storm and made landfall near Atlantic City, bringing up to 6 inches of rain to southern New Jersey and Delaware. We were actually spared from most of the rainfall, and as it turned out, our rainfall forecast was grossly overdone since some dry air was wrapped up into the system as Faye headed north. And the strongest winds also stayed just to the west of our region as well. They kind of brushed into parts of southwest Connecticut, but really spared most of southern New England. And here's a look at the rainfall from Faye. You can see the track here in the white. And with most of the tropical systems here in the Northeast, as they undergo what's called extratropical transition, or kind of turning into an ordinary coastal storm, the heavy rain gets focused to the left of the track. And this is another example of that. We saw that with Irene. We see that with Isaias. We see that with most of these. So the heavy rain really doesn't fall east of the track. A lot of times you get a lot of dry air in and you're left with almost nothing. And as you can see here in New England, less than 1/10 of an inch on average. We really didn't have very much. We did have some gusty winds, but certainly nothing too damaging. As you can see, the strongest winds were observed much farther to our southwest, southern New Jersey, Delaware, where Faye actually made landfall. Some gusts up to 40 miles per hour or so across Long Island, and even a 32 at Bridgeport. But by far, southern New England was spared from the worst effects of Faye. Then into August, another severe weather event. This was kind of an isolated one, but we actually had an EF0 tornado out in western Massachusetts. Storm Prediction Center actually issued a tornado watch that day, as you can see here, which included the western third of Massachusetts and most of Connecticut. At 5 p.m. that day, just taking a look at the weather map, you can see a warm front was lifting here through southern New England. And this is a fairly common setup for tornadoes in our region. This area here behind the warm front we call the warm sector. Notice how the temperature is in green, that's the dew point. Start off in the 60s here in the cooler air ahead of the warm front, but in this warm sector you can see 73, even a 78. This is more tropical air. Temperatures are in the 90s and 80s in this area. So whenever we get a tropical air mass in the area with dew points above 70, usually a warm front nearby that tells us we have a lot of low-level wind shear, which is turning of the winds with height. That's a very favorable setup for tornadoes in our part of the country. And in fact, that's what happened. It wasn't a widespread event, but certainly one storm here, an isolated supercell developed. It tracked from the northwest part of Connecticut over into western Massachusetts and produced a weak EF0 tornado. You can see there as it goes through. And something we look at are called low-level rotation tracks. This is a composite of the rotation that's being measured by the radar and kind of plopped onto one map so you can kind of see the track. And this is valid from 5 p.m. to 9 p.m. Now, while most thunderstorms have some sort of weak rotation, as you can see here by these gray or lower values, the stronger storms are the ones that have the tornadic potential. And you can see this single track that goes all the way from Connecticut into Massachusetts. And typically when you see values getting up into these yellows or even reds, that's pretty tight and persistent rotation. So that's what we look for the process of issuing a tornado warning. And in fact, it was as it reached this area that it did produce a tornado. And here was some of the damage reports you can see on the left from that afternoon that we received. A lot of wind damage, Hartford County, Tolland County, over into Hampton County in Massachusetts, a number of trees down, even a power pole snapped. And then we ended up doing a storm damage survey. Harder to do in COVID times because we have to travel solo or in separate vehicles, but we were able to do that and went out to Sandusfield in Berkshire County along with our friends from the Weather Service in Albany. And it started in Sandusfield over to Blandford. Not a tremendously long track, but actually, almost 8 miles, but I'm sorry, not necessarily a wide track, 100 yards. This was an EF0 tornado with maximum winds of about 80 miles per hour. So you can see some of the details from our final report there. So kind of an interesting day. We thought it would be maybe perhaps a little bit more of a severe weather outbreak, but we just ended up with the one isolated tornado. So with that, I'm going to pass it on to Rodney, who's going to talk about the second half of 2020. He's going to start with Tropical Storm Isaias. So Rodney, take it away.
Well, thank you very much, Joe. This next tropical storm that we're going to talk about is the Tropical Storm Isaias, which happened in early August. It actually made landfall in North Carolina as a Category 1 hurricane, and then, due to its small inland track, Isaias' main threats for southern New England were really the damaging straight winds, and along with elevated risk for some spin-ups and storm surge as well as coastal flooding. So most of the damage actually ended up happening in eastern Massachusetts and Rhode Island, from up to 60 mile per hour wind gusts, and it was, kind of like as the line was pivoting through southern New England, and really the major impact from this storm were the hundreds and of thousands of people who lost power in the aftermath. And this is a quick look at the track of the tropical system. You can see it. It briefly re-strengthened to a hurricane before making landfall in the Carolinas, and then I pretty much hugged the eastern seaboard and going up through Hudson Valley into Canada. And these are some of the observed wind gusts, highest wind gusts that day. You can see that the stronger wind gusts were observed towards New York City, and part of the reason for that is because the dew point the temperature actually were a little bit higher. That allowed for more mixing, brought down some of the more damaging wind to the surface. And these are some of the photographs and videos from Isaias. And this is a look at Eversource data for Connecticut. You can see Connecticut was pretty hard hit by the tropical storm. A lot of people without power for days, up to a week. And this is a look at the Massachusetts power outages, over 200,000 during its peak. And this is the observed precipitation. You can see because of the more inland track, flooding concerns for us were not too big of a deal and you can see the bulk of the precipitation fell kind of along the Mid-Atlantic coast up through upstate New York. And the next event is the October 7th derecho, and that's actually a line of severe thunderstorms that held together actually, for all the way from upstate New York near Lake Ontario, and then actually held together and persisted through Boston and the Cape and Islands. So very, very impressive severe thunderstorm, long-lived squall line. And initially, the concern is that there's not going to be enough instability to generate a line of storms. But because of that line, it really helped to bring down some of the more damaging winds to the surface. Widespread 70 to 80 mile per hour gusts reported across southern New England, and to add to the fun, there was even an embedded EF0 tornado that actually touched down in Millis, Massachusetts. And of course, from a storm survey standpoint, when you have widespread straight line wind damage, it is very challenging to differentiate between potential tornadic signature in an area with straight line wind damage. So it was kudos to our warning coordination meteorologist Glenn Field for being able to identify the tornadic signature when he did the storm survey. And this is on the left. You can see the swath of the wind reports, and you can see might be hard to see, but the single red dot, that's the tornado report. But for the most part, it was straight line wind damage, and again, a lot of people lost power as well. Up to more than 200,000 across Massachusetts. And this is a radar loop on the top right. That's the reflectivity loop. On the bottom right, that's the wind radar wind signature. So you can see how the line really held its act together, and actually strengthened a little bit as it approached Massachusetts from the northwest. And then on the right, you can see the wind. Green and red represent different opposite directions, and you can see some blue shading as well. That's really strong winds. Not too far from the surface. And this is again a closer look at the wind signature. So as the derecho punched through southern New England, and all the yellow polygons, those are severe thunderstorm warnings, and the blue polygons over the ocean, that's the special marine warning for the mariners. And this series of images show how the EF0 tornado evolved. You can see towards the center of each image, you can see this is what we call a rear inflow jet. And that is something that we look for, trying to identify potential tornadic signature on radar. And that's, that's basically the inflow towards the tornado. Okay, so switching from rain to drought, I'm sure many of us remember the first half of 2020, or rather the center part of 2020. We were in a very dry weather pattern. So we had a cold and wet spring in April and May, and then we just kind of dried up, and the dry weather pattern started in June and lasted through November. And during the worst of the drought, many places experienced what we call severe drought conditions, especially in southern Rhode Island and southeast Massachusetts. And thankfully, the conditions improved in November and December thanks to multiple storm systems that brought heavy rain and snow. And this is to illustrate the extent and longevity of the drought. You can see the brown line. That's the normal precipitation accumulation as we progresses through the year, and the green line is the 2020 accumulation. So for the first half of the year, our precipitation was very close to normal, and then kind of mid-May onwards, it really plateaued as we struggled to get any meaningful storm systems to add to our precipitation total. And when finally, kind of mid-October, we flipped the switch and began chipping away at the precipitation deficit. And this is, a perspective from Rhode Island. It's Rhode Island's driest, 3 months on record, July to September, and second driest on record for June to September, and as well as August to September. So no matter how you slice it, it was very dry. And one of the first systems that actually helped us to flip the switch was the early season snowfall that we received late October. So some of you may remember that we actually had tropical moisture from Zeta, and combined with very cold air, and that led to several hours of moderate snowfall. And so when we forecast snow, so it is not only important to get the QPF or the liquid correct, it is also important to get the snow to liquid ratio correct, because fluffier snow accumulate differently from heavy wet snow. So in this case, even though it is an early season snowstorm, the snow to liquid ratio was actually very high because of the, prior to the system, there was an Arctic air injection. And, some of you, especially if you live away from the immediate south coast, you may remember that the snow was very fluffy, and it's not the kind that you would expect from an early season snowstorm. It's almost like a midwinter snowstorm because the air is so cold. And at first we issued winter weather advisories, despite the expectation that the snowfall in most locations would fall below the criteria of 3 inches. So initially, even though we didn't think it's going to be 3 inches or more, we felt because it's the first snow of the season, the drivers may need to get used to winter driving conditions again. So we issued an advisory, but it ended up actually, a lot of places actually, hit, high-end advisory criteria and even low-end warning criteria snowfall because of the high snow to liquid ratio. So even with limited moisture, there's a lot of fluff in the snow, and therefore we were able to accumulate snow efficiently. And this is a look at observed storm total snowfall. Again, most places 4 to 6 inches, Worcester Point East, and there were select locations that received over 6 inches, which would be warning criteria snowfall. So very impressive for an early season snow. And this is the satellite view of the snow on the ground the day after. And so one interesting thing about this image is you can see the rain-snow line just kind of hugging the boundary between Bristol County and Plymouth County in Massachusetts. And for locations close to that rain-snow line or the coastal front, the snow was a little bit heavier and wetter, and the number of power outages in that vicinity is higher than the rest of the region because the snow is more heavier and wetter. And impactful storm for parts of the region. There were crashes and spin-offs across southeast Massachusetts and Rhode Island. And back to a slice of severe weather in late November. So we actually had a water spout over the Cape and Islands, November 23rd, off Martha's Vineyard, and it was a pretty rare event that late into the season. So this is a look at the different parameters that at that time. You can see there's a weak surface low, but then there's also marginal instability near the surface, and there's a lot of shear as well. And wind shear, for those of you who were not familiar with the concept, is basically the change in wind speed and direction with height. So the higher the wind shear, simply put it, the more spin you add to the atmosphere to generate storms. And this is basically looking at the radar signature, and what Joe is pointing at right now is the how the red and the green, that's basically wind pointing in opposite directions. So where they meet, that's that kind of indicates rotation, and then on the right hand side you can see that's the rotational track that again would give clues to a possible water spout or tornado. And this is actually photographic evidence of the water spout. And going back to winter again, December 5th interior winter storm. So remember the October 30th snowstorm, even though it was early season, we had Arctic air in place and the snow ended up being very fluffy. The December 5th winter storm, actually, there was no cold air in place, or marginal cold air in place. And the challenge became, we were not lacking in moisture. We had well over an inch of liquid for many locations. But the problem is that, even though the temperature profile would suggest, it's going to be a mainly rain event for many places away from the high terrain, the expectation was that the storm would be intense enough to generate its own cold air. And when that happens, that would lead to atmospheric cooling and flip the rain over to heavy wet snow. And a lot of the guidance were hinting at that, and it was a very challenging storm for us, because even though temperature profile may not support snow, just from a dynamic standpoint, the expectation is that we would receive heavy wet snow, and it doesn't take much heavy wet snow to cause issues like power outages. So it's a very challenging storm for us. And the other thing that is the track of the surface low. Some of you may have heard of the benchmark. Basically, it's 70 degree west, 40 degree north. If the surface low track near the benchmark, you can expect accumulating snowfall from the Providence to Boston corridor. And basically what happened was that the surface low actually tracked a little bit further west than what the model suggested. And when you have when the surface low tracks a little bit further west, it kind of brings the rain snow line further west in our region and away from the I-95 corridor. So even though some of the models were showing, up to 2 inches per hour snowfall rate over eastern Massachusetts, it just wasn't cold enough to generate heavy wet snow in the end. And so, even though the high-res model output were all saying like widespread 6 to 12 inches snowfall over eastern Massachusetts and Rhode Island, they really did not fit into the larger scale pattern very well. So there was kind of a red flag. And this is the observed precipitation and taken from rain and the melted snowfall. You can see, wow, this Rhode Island, Southeast Massachusetts received over 2 inches of liquid. So you can imagine if that was snow, even just taking 10 to 1, that would be a lot of snow. And this is what ended up happening. So it was a really elevation dependent winter storm. Locations towards the Worcester Hills and Connecticut Hills did the best with this storm because they were just high enough and cold enough for the bulk of the precipitation to fall as snow. But away from the high terrain, the snow gradient really dropped off. And this is the number of power outages, 30,000. It's not a small number, but then again, it's far lesser than what we would have expected from a heavy wet snow event. And the December 16 to 17 winter storm that so far this season is the biggest storm for southern New England. Hopefully it's not the last one. And 3 factors that led to heavy snow in the Northeast. First, very strong mid-level convergence and frontogenesis. Secondly, strong low-level easterly flow. And third, coastal front. And with this kind of setup, we usually would see 2 bands of heavy snow, one further inland and one closer to the coast. And this was an overview of what transpired over Northeast US. So you can see the surface low pretty much tracked almost parallel to the mid-Atlantic coast down to the south coast of southern New England. And you can see the swath of heavy snow stretching from north central Pennsylvania through upstate New York into southern Vermont and New Hampshire. That was your 40-inch plus zone, and some places reported 5 to 6 inches per hour snowfall rate, which would be impressive enough for with lake effect, but this is not lake effect. So just really tremendous amount of snowfall in a short period of time. And but even for us here in southern New England, it's not a bad storm. I mean, it's pretty impressive. Boston received over a foot of snow. Worcester came close, and even for Hartford and Providence. So it was a pretty good storm for us, and it broke the daily record snowfall. And this is the wind speed at around 5,000 feet. You can see what we call a speed convergence. So the brighter colors will represent higher wind speed, and the green color, that's lower wind speed. So if you think about it, on a highway, you have a very fast cars behind you, and let's say you're traveling very slowly, that would kind of lead to collision. And that's basically what happened at 5,000 feet. There was a collision of air at that elevation, and that led to a lot of lift. And the more convergence, the more lift, that supports a band of heavy snow. And again, and this is lower down. So notice there's a band of a strong easterly wind, and with a strong easterly flow, that's you bring the moisture from the ocean and basically slam it into the region of upward convergence and lift. And north and west of the best convergence, that's where you get the heavy snow, and that was exactly what happened. You had heavier snow from northeast Pennsylvania into upstate New York. And I believe this is the last event we're going to cover for 2020. So that's the Christmas Day storm. The snow was on the ground for most days leading up to Christmas, but then most people did not see a white Christmas on Christmas Day because of this storm. We had 50-degree dew point temperature, that what we call a snow eater, and also we had on top of that we had 2 to 3 inches of rain that just really wash off any snow pack that has remained. And this is the wind speed, kind of a little bit lower than the worst case scenario because the temperature did not quite reach expectations, and less damaging winds were able to mix to the surface. And again, this is the look at widespread 2 to 4 inches of rainfall across the region. And there were some flooding issues, especially out west where there's a melting snowpack, and on top of that you have heavy rain, so that really led to minor to moderate flooding, especially of the smaller creeks and eventually the bigger waterways. Okay, so at this point, so we will take questions for now before we move on to the winter weather briefing.
Okay, thanks, Rodney. Yeah, we'll go through a few questions here, but if we don't get to yours, or if you think of something later, feel free to send me an email and we will answer that for you. Let's see. We got a few hellos from John and from Dave. Hello, gentlemen. From Stephen and Rodney, I'll give this one to you. Do you have a recommendation for a meteorology and a climatology book for someone with a strong science background, but no courses in these two areas? So I don't know if you have any ideas, Rodney. Meteorology and a climatology book, someone with a science background.
Yeah, thanks for that question. The first book that I think of is it's called Meteorology Today, by Donald Ahrens. The last name is Ahrens, and that's just my personal suggestion. Nothing official, but I do find that book pretty useful, and it has enough bandwidth to accommodate beginners to intermediate users.
And Rodney, that was actually the textbook I used for freshman meteorology course back in college years ago. So it's a very good book. Anything on climatology, Rodney, that you would know?
Yeah, that's a great question. I actually got most of my climatology education, but really, well, actually, there's actually a book. It's called Climatology, actually. It's by Robert Rowley, Rohli, and Anthony Vega, Vega. I believe that was the book. That was the textbook that the professor used when I was taking a course at. I used to work for the Navy, and I took classes at the Naval Postgraduate School, so that was the textbook that we used for the climatology class.
All right, good questions. Just a couple more here, and then we'll get on to our storm briefings. From Samuel, and this actually has to do with the Monday storm, but we'll answer it now. Why do the TV weather folks try to make an early call with differing snow amounts than the NWS when it's not set in stone? Are they not using the same models you do? Yes, Samuel, the answer is yes. We're all looking at the same data. There's differing opinions out there. I think if I took, say, 10 forecasters in our office and told them to come up with a snowfall forecast, we might have 10 different answers. There's a lot of, subjectivity and maybe a little bit of a bias here and there, or a little more, someone's got a little more knowledge than somebody else. So, for Monday, it's certainly an early call at this point. I'm not aware of anyone putting out numbers. Maybe they are, but yeah, it's a little bit too early, being several days out at this point. But everyone's pretty much looking at the same data online and otherwise. So, it's up to the individual when they want to put out their forecast, really, I think, more than anything else. Let's see, and from Benjamin, when do you think the next blizzard will be? Well, if you're talking Cape Cod, it could be tomorrow locally. Or, we may be looking at some near blizzard conditions early next week. So we'll just have to, that's something you really can't tell with a potential blizzard until you're almost within about 24 hours, because there's so much that could go wrong, getting the wind and getting the visibility for the minimum 3-hour period. But, we'll see. We're getting into the time of year now, late January and February. That's typically when we get our strongest winter storms and our greatest potential for blizzards. So hang in there, Benjamin. We'll kind of see what happens. And let's see, a question from Dave. With Tilt 1 on velocity products, how high up from the radar site per every 10 miles is the radar seeing the wind information? And if you see 100 mile per hour winds at a given level, how do you accurately extrapolate that down to the surface? Ooh, I'll take this, Rodney. Good question. So yeah, it just depends on the distance from the radar. So, across much of eastern Mass and Rhode Island, the beam is only a few thousand feet above the ground. When it gets out to western Mass, Hartford, Springfield, out in that area, the center of the beam typically is about 5,000 to 6,000 feet up. So obviously we're sampling the wind there much higher. And it's harder to extrapolate that down to the ground. Usually what we do is we take a percentage of that, but sometimes that works and sometimes that doesn't. It's just kind of based upon our experience about how much wind we think is happening. So a lot of the times when we're farther away from the radar, we're looking at that reflectivity signature, looking for a sharp gradient from nothing to really high reflectivity. Think of the reds and the oranges. That will show us quite often that there's the potential for wind damage. Something's going on that we're looking at. So it's definitely a challenge being farther away. Let's see, from John, favorite weather event was the 23rd August 2020 severe weather outbreak. Is it correct we typically don't see mid-level lapse rates as strong as that? Yeah, that's true, John. It's rare for us to have really good mid-level lapse rates. Normally they're pretty weak, and we have to overcome that by more instability. But that was a case where we actually had some good lapse rates. So there you go. Rodney, I'll handle this. Just a few more here. Rodney, for you, from Gabriel, do local forecast offices issue tropical storm and hurricane watches and warnings, or is there a different office that takes care of those alerts?
Yeah, thank you, Gabriel. We are the office that issued those tropical storm headlines, but there's a lot of collaboration behind the scenes with the National Hurricane Center down in Miami, Florida, and also we collaborate all the time with our neighboring offices to make sure that we kind of have consistent headlines and messaging.
All right. Let's see, from Brian, do you guys think this 2021 severe weather season will be more active this year or less? You want to handle that one, Rodney? I don't have a clue.
Yeah, sure. I don't have a clue
either,
Brian. It's I would say, well, let's get through the winter season first, and then we can talk about severe weather.
We'll get back to you on that. Yeah, that's always a tricky call because there's so many things that go into it, more so than winter. From Kevin, how were liquid to snow ratios used in forecasting the October 30th snowstorm, and how are they applied to forecasting? So basically what we do is we look at the temperature profile in the atmosphere and kind of where the lift is centered. If it's centered in the colder air, you're going to have higher ratios. If it's centered in relatively warmer air, then you're going to have lower ratios. So we kind of use that. The computer models actually do a fairly decent job at estimating that for us, but sometimes we do have to adjust what we get from the computer models because they're not focusing on exactly where the lift is. So it really just depends where your strongest lift is. Is it low in the atmosphere where it's milder, or is it higher up in the atmosphere where it's a lot colder and you get that fluffy kind of snow? Comment from our friend Jonathan, the book Climate History and the Modern World, H. Lamb, is a classic book by one of the giants in the field. So there you go, Climate History and the Modern World by H. Lamb. You can give that one a try. From Ethan, how do you get radar data over the ocean for coastal storms? Aren't they too far away to get accurate returns? Yes, they are. The radar in Taunton, the radar in Long Island, the radar up in Portland, those get a reasonable look, at the nearshore areas. But for far out over the ocean, we don't have radar data, so we rely more on satellite. And that's where the new GOES 16 comes in. It gives us a lot more information, as much as at least, little as every 1 minute we get a scan if we need it. But there's a lot more data we use by satellite to help us augment kind of what we can't get from the radar. So that's just a problem with not being able to put a radar in the middle of the ocean. So one more question from Ethan, and then we'll move on to our briefing. In the winter, you can get a decent amount of strong low pressure, but what would the effects of strong low pressure be in summer? Would it cause more severe weather? And Rodney, I'll handle that one to you.
Yeah, thank you, Joe, and thank you, Ethan. So climatologically, that's actually a great observation. First thing, in winter we tend to get stronger pressure gradients, and that's really because of a more energized jet stream in the colder months. And the jet stream is, basically a result of temperature gradient between the polar regions and the tropics. So in the summer, you think about it, the northern hemispheric summer, the polar regions and the tropical region kind of have, less of a temperature difference. And the result of that is a weaker jet stream and, less pressure gradient near the surface to create, storms. But in winter, the opposite is true. You have a strong pressure gradient and temperature gradient between the tropics and the polar region. So you get more strong low pressure systems. So, in the summer, if you take a look at the surface map for this in a severe weather setup, you don't necessarily need a like a 980 low to get severe weather. But when they happen, they tend to be with a tropical system. If you think about Tropical Storm Isaias, Tropical Storm Faye, if you look at the low pressure, it deepens pretty rapidly. But that would be a different kind of severe weather. So I hope I've given you a good answer to your question.
All right, and Ethan, if you have any more questions, feel free to send me an email, and we can chat a little more back and forth. But good questions. Okay, so from here, I'm going to hand it back over to Rodney, who's going to talk about the potential for ocean effect or an ocean enhanced, technically, snow on Friday and possible near blizzard conditions on the Outer Cape and Nantucket. So we're really most concerned the area on Cape Cod east of Hyannis, especially from Provincetown through Truro, Eastham down to Chatham, and then perhaps also even on Nantucket. So those are kind of the target areas we're looking at tomorrow. I'm going to let Rodney go through this because he's been on the forecast desk on the night shift all week and has been watching this, and I know he's very excited for it. So I'll go ahead, Rodney, hand it to you.
Yeah, thank you, Joe. Once again, this is